pairs, it will go on 6 and we have 2 raised to power 4 here, right? Now, when divide 2 raised to power 16 by 17, remainder is 1, okay? And then you have 2 raised to power 4, that is 16. By 17, finally I can say remainder is said to be 16. I hope the idea is clear. So in these type of questions, we have simply seen that either we try to make the difference to be 1 or minus 1, or after getting to be 1 or minus 1, it's easy. And if you are not taking to be 1 or minus 1, then if that number by which you are dividing, if that's a prime number, then in that case, you may apply our basic concept a raised to power p minus 1 by p, remainder will always be equal to 1. These are the first type problems. Now we take the second type problem here. That is based on this theorem that I earlier told you. 32 raised to power 96 by 97. Can you tell what is the remainder? Easily. Because 97 is a prime number. We know that 32 raised to power 97 minus 1 divided by 97, remainder is 1. So my answer is simply said to be 1. So I can say remainder is 1. Let us take the second question here. 2 raised to power 145 by 73. We have to find the remainder because 73 is a prime number, right? So I can say that if you have 2 raised to power 72 by 73, remainder will be 1. So what I can say, I just make it as 2 raised to power 72 by 73. In that case it is 1, but here my power is 145. I make the power 2 into 2 raised to power 1, right? Now from here remainder is 1. 1 into 2 by 73. So finally I can say remainder is said to be 2. That is my answer. Right? Take the third question here of this type. 205 divided by 17 raise the power 52. Okay? Same concept. 17 is a prime number and we can say that nothing is common between 205 and 17. So what I can say, I just make it as 205 raised to power 16 by 17, remainder is 1, right? Here we have 52, so I just make it as 3 into 205 raised to power 4. That I will make, right? Now, from here I will get my remainder to be 1, and now my question is simple. 205 raised to power 4 by 17, we have to find the remainder. When we divide 205 by 17, we can say that 17 will go on 1, 35. It will go on 2, so I am saying at 201 plus 1 raised to power 4 by 17. It's a multiple of 17, hence I can say my final remainder is said to be 1. Or otherwise also, if in the starting you also divide, in that case you can get your remainder to be 1. Okay? Then we have third problem here, because in this session we are primarily concerned with the taking of the different problems of remainder theorem. I expect from you, before watching this session, you watch my earlier session of remainder theorem. What is the question is 2 raised to power 469 plus 3 raised to power 268 divided by 22. We have to find what is the remainder. That's our question. 2 raised to power 469 plus 3 raised to power 268 by 22, we have to find the remainder. Okay. Now, when I look at this problem, I take two cases individually. First, I take this 2 raised to power 469 by 22. I can say 2 can be cancelled out. 2 raised to power 468 by 22 by 11. Sorry, 2 will be cancelled out. I get that value to be 11. Right. Now, we can say 2 raised to power 5 is 32. And 32 when divided by 11, remainder is minus 1. I make it as 2 raised to power 5. 5, 9, 45, 18, 5, 3. So my remainder is 3 divided by 11. Right. I may take it as 32 raised to power 93 into 8 by 11. Remainder is minus 1. So that is said to be minus 8. Okay. Minus 8 means my remainder is equal to 3. In the starting I have cancelled 2. So I have to multiply by 2. I can say my remainder is 6. That you can say. Take the second one. 3 raised to power 268 by 22. Okay. Now here also we try to make an association between 3 and 22. 3 cube is 27 by 22. 3 raised to power 4 is 81, 3 raised to power 5 is 243, right? If I divide 243 by 22, I can say that 22, 1, 22, 23, 1, right? I will say, I try to break in 3 raised to power 5. 3 raised to power 5, it will go on 5, 5, 25, 18, 3 into 3 raised to power 3 divided by 22. Okay. Now this is taken as 243 raised to power 53 into 27 by 22. Right. From here remainder is 1. So I may say 1 into 27 by 22. So finally I can say remainder is said to be 5. Okay. Now I can say that from this portion my remainder is 6. From this portion remainder is 5. So finally I can say 6 plus 5 by 22. So I can say remainder is equal to 11. 11 becomes my answer. Okay. In this question what we have done, we have taken these two parts individually and individually we solved them. Right. After solving them, we can say our final remainder is said to be 11. 11 becomes my answer. Okay. Let us take the next problem here. That's our statement number 4. It is given that 7 raised to power 7 plus 7 raised to power 77 plus 7 raised to power 3 times 7, and this sequence goes up to 7 raised to power 7 times 7. It is given that we have to divide this number by 8 and find the remainder. That's my question. Now when I look at this problem, I know that when 7 is divided by 8, my remainder is minus 1, and power of minus 1 is odd. It means it should be minus 1. Okay. Similarly here, minus 1, here minus 1. So here my pattern is that is given for 7 times. So I may say minus 1, minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. So I am getting to be minus 7. Okay. Now this minus 7 is divided by 8 because it is a negative remainder and we have to convert it into the positive one. So we know that when negative is converted into positive, so I have to add this. So I may say minus 7 plus 8, my answer is said to be 1. 1 becomes my answer. Right? Here I can say answer is equal to 1. Next, problem number 5. Question here is, it is given that 2851 into 2862 whole square, 2862 square into 2873 cube. 2873 cube. We have to divide this whole number by 23 and we have to find the remainder. Right? That's my problem. Now, in order to answer this question, first we find individually. 2851 by 23, it will go on 1. Right? I am getting 55, it will go on 2, 46, 91, 21, 3. So I am getting to be 69, my remainder is 22. Similarly here, if I divide 28 by 23, it will go on 1, 26, it will go on 1, 32, it will go on 1, remainder is 9, I make it as 9 square into. Now, if I divide this by 23, 1, that is 57. Okay, sorry, we have committed a mistake here, I hope. That is 23, 1, so we are getting to be 556, 23, 2, 46, 102. Right, we know that 23 forza is equal to 92, my remainder is 10. So here I can say that is said to be 10 square into. Now, if I look at this, 23, 1, 57, 23 to 46, 113. So I can say 23, 5, 115. So here I can say remainder is minus 2. Divide by 23. Okay. Now what I can say? 22 when divided by 23. Remainder is minus 1. You may take it. 100 by 23 remainder is 8 because 23 4s are 92. Similarly, minus 2 cube is minus 8. Okay. I have to divide this by 23. Now, 64 by 23. You can simply divide. 23 to 46. Right. So here I can say my remainder is said to be 18. So my final answer is said to be 18. I hope the idea is clear. Very simple problem. You have to just take individually. Individually you have to comment What are the remainders? So here I can say it is 22, here it is 10, here it is minus 2. Okay, because it's square, make it as 100, 100 by 23, remainder is 8, this is minus 8 and this is minus 1. So finally I can say 18. 18 becomes my answer. Let us take the next problem here. Question number 6. 10 raised to power 10 plus 10 raised to power 100, 10 raised to power 1000 up to 10 zeros. 10 raised to power 100, 10 raised to power 1000 and this goes up to 10 raised to power 1, 0, 0. Total zeros are 10. 2 to 4 to 6 to 8 or to 10. It is given that we have to divide this whole sequence by 7.